record before I forget. And okay, so I'm hoping everyone watched the pre-recording I did last week. That was for hypothesis testing for proportions. So let me just give you a rundown of what we've done so far. Let me share my screen. Okay, just give me a heads up if you can see the whiteboard. It says Moya's, I didn't pronounce it properly, recently launched. Fantastic. All right. So I'll just write here on the left. What we've done so far for learning unit 8 is we've done hypothesis testing. That's pretty much what learning unit 8 is, right? Hypothesis testing. That's what we've covered. But there's different cases. So the one case, the first collab for this learning unit that I did it on averages. All right. And the second one, which I wasn't here for, but I gave you the pre-recording, that's for proportions. Okay. Now for averages, for number one, it can either be the Z table, or in other words, the normal distribution, or T distribution. All right. Now I've only covered Z. Okay, so for one, I've only covered Z. I haven't shown you how to use the T distribution. And that's what I'm going to finish off today. All right, so that's where we are at the moment. And to show you how to use the T distribution, I've got this problem on this whiteboard here. So let me know if you can't see it. Otherwise, I'll just assume that you can. But I'll read it to you, and we'll walk through it together. So it says, I'm not going to pronounce that. Recently launched a new flavored pudding. The marketing manager now wants to assess product success. Cannot hear me. Okay, Kalisha, can you not hear me? Everyone else? I'm just trying to check that. Okay, Kalisha, I think it's your side. Yeah, Kalisha, I'll wait. I'll give you a few minutes. Just try and do that. Kalisha, did you log on? Oh, you can. Okay. All right. Fantastic. I'll get back to it. All right. I'll read this again. So it says, Moya's recently launched a new flavored pudding. All right. So it's a new product. The marketing manager now wants to assess the product's success in the marketplace. All right. If average sales per week are less than 5,500 per outlet, the product will be withdrawn. Okay, so you can consider it a failure and they will scrap this product. The results from a sample of 18 supermarket outlets countrywide showed that the average sales per week was actually 5,275 rands. The sample standard deviation of 788 rands. So assume weekly sales are normally distributed, and hold on, yeah. Should a new pudding flavor be withdrawn, advise the marketing manager by performing the appropriate hypothesis test to 10% level of significance. Also show the null and alternative hypothesis for this test. Okay. Now in this problem, I actually want to remove this. Okay, I want to forget that this was here. Okay. All right. Let's ignore this part here. Okay. This wasn't here. Now, what this question is telling you is you have 18 outlets. So there's the sample, all right, for your supermarkets countrywide. There's only 18 of them. Each X is a supermarket. 1, 2, 3, all the way till 18. So this is the 18th supermarket. You can say this is 1, this is 2, 3, and you can see where I'm going with this. 18 supermarkets, right? That's your sample size. Okay. And now this product was launched, and to determine whether it was a success, they looked at just a sample of 18 supermarkets. All right. So that's your sample size, N, which is 18. Okay. And now what they're telling you is to test the hypothesis. Okay. So you know you're doing a hypothesis test if you look at the question. Right? There's a question, hypothesis test. Now, reading this question, first identify, are you testing averages or are you testing proportions? Maybe just read through this text quickly and put that answer in the chat. Are we testing averages or proportions? Yeah, very good. Yes. Everyone sees it. Well done. Nice. So we're testing averages. So that means we're testing mu. Mu is the symbol for averages. So you're going to have H naught, right? And you're going to have H1, null, and alternative. H1 is your alternative. So we're both dealing with mu here. Okay. If you read this question, and I'm going to underline this part here. Less than 5,500. Okay. So here in this, here in this question, we want to look at whether it's less than 5,500, because what they're saying is, if the average, we take the average sales for these 18 supermarkets, and if it's less than, we're going to test with it's less than 5,500. Okay. If it is, we're going to cancel the project, the product. If not, we'll continue with the product. All right. Now the less than 5,500. Now, if you call from the last, even the recording and the first call I ever did in this learning unit, I said H naught will always take these three signs. It'll take the equal to, or it could take the less than equals to, or it can take the greater than equal to. But if you look at here, it's saying less than 5,500. Now we know the sign for less than, strictly less than, is this. Right? So this sign will obviously have to go in H1, because these are the only signs that can go to H naught. So this will go to your H1. So we're testing whether it's less than 5,500. And what's the opposite of less than? Is it this one? 1? Is it option 2? Is it option 3? What's the opposite of this? What's the opposite of this sign here? Is it option 1, 2, or 3? So remember, I'm looking at less than, and I want to know what is the opposite of that, or the complement of that. Yes, everyone sees why it's 3, right? If this is less than, the opposite must be greater than equals to. So that's what goes in H naught. It's the opposite of that, 5,500. So that is our H naught and H1. Okay, that's our H naught and H1. And if you read this part here, it says if the average sales per week is less than 5,500, it will be withdrawn. So we'll put a note there for less than 5,500. That means when this H1 is found true, then that means you're going to withdraw the project, the product. Okay, and H naught you will continue with product. All right, but all we want to know is whether we can withdraw it or not. That's our H naught and H1. Now, when you have inequalities in your H0 and H1. That means what I'm saying inequalities, equalities when you have this, when you have that, and when you have this. Okay, but you can see in this case, we don't have these two. We have inequalities. That means we have less than and greater than equal to. That means it's a one-tailed test. Okay, now is it a lower or is it an upper tail test? And how I remember that is I use the sign for H1 to kind of resemble an arrowhead pointing to where the rejection region. Yes, very good, Kay. Very good. Yes, it's lower. Okay, so that means it's a lower tail test because I'll think of this as an arrow pointing to the left. So it means if I had to draw it, just a rough sketch, lower tail means it's on the side of rejection agents here. All right, so I'll put a note there. Okay, if you need to put a note here, you can just say lower tailed test. All right, that's your step one, the hypothesis testing. Step one, declare your hypothesis. All right, remember there's 5 steps to hypothesis testing. The next step is we're going to find our rejection region. So I'm going to put a note here. We're going to move to step 2. Now I'm going to do step 2. Let me just draw a line to separate it. Okay, now we're moving on to step 2. All right, step 2 is to find the rejection region. Now, this is where you have to determine whether it's a t-distribution or a normal distribution. When it's a normal distribution, we use the Z table. When it's a t-distribution, we're going to use the t table, and I'll show you where that is in your book, in your textbook. All right, so how do we know which one we're going to use? Yeah, very, very good. Yes, when your sample size is smaller than 30. Yes, very good. Okay, how do you know you use a t? Then if your sample size is less than 30, which is the case here, all right, that's a dead giveaway that you're going to use a t-distribution. There's also one more criteria that you can check for. I want you to look at this part here that I'm going to underline with a sample standard deviation. Yes, not normally distributed. Yes, very good. This part here that I've underlined with a sample standard deviation. What that's telling you is that you have the standard deviation of the sample, just of these. That means you have the symbol S, which is actually 788. It's given 788. You don't have the population standard deviation, that is the sigma. Okay, you don't have this. And when that is the case, when we don't know this, but we know this, and the sample size is less than 30, you use a t-distribution. Okay, that's your criteria for using a t-distribution. All right, now that we know that's the t-distribution, I'm going to sketch the t-distribution. To know what a t-distribution looks like, it looks very, very similar to a normal distribution. Here's your textbook, and I believe it's page 507. You don't have to turn to it, but I've got it on the screen here. If you look at the diagram in the top right, it looks very similar to the normal distribution. There's the normal distribution on the previous page. It's a bell-shaped curve. The t-distribution is exactly the same. It's symmetric, all right? But I'll show you the differences now. So we're going to sketch this curve here. We're going to sketch that. So here, our axis. Okay, and I'm going to try and do it as best as I can. Just like the normal distribution, it is also centered at 0. And this is your t-axis here. All right. Now remember what we said here. We said it's a lower tail test. That means the rejection region is on the lower side here. There's our rejection region. And the size of this area is given to us by our, alpha, or our level of significance. And there's our level of significance here, 10%. So the entire 10% goes here. That's the size of the area, 10%. Or you can write 0.1, same thing. Let me just write 0.1 instead. Okay, same thing. We need to work out what is this value on the axis. That will determine whether we're going to reject or accept H0. So from here, let me just thing here to here, all the way to the left of this, whatever this value is that we get here, whatever this value is, anything on the left of it, you're going to reject H0. Now, how do we find this value? So the thing is, because the t distribution is also symmetric, you're going to do the same trick you did with the normal distribution. Okay? If you know the positive equivalent, so whatever, say you knew the positive area here, let me just sketch this in green. Right? Its equivalent counterpart on the right. If this was 0.1, say hypothetically that this value that we found in our table, and I'll show you how to find it for now. Let's just assume hypothetically it was 1.2. I'm making this number up. If this was 1.2, then this number here would be negative 1.2. Everyone get that? It's because of the symmetry. Before I move on, so make sure everyone understands that. Good? Fantastic. Very good. All right. So remember, I made up this number, but I'm going to show you how to find it now. So we're going to find the positive number, and we're going to just put the negative sign and place it here. All right. Now, if you look at the t distribution table, and I guess get frustrated about this at times, but the t distribution should ideally be in a similar format as your normal distribution. But for some reason, in this textbook and in your exam, you're going to be presented with the tables like how it is in your textbook. And unfortunately, you just have to work with it like that. Now, why it's, I guess, a bit annoyed with it is that the t table, this table that you have here, it's actually you read it the opposite way of how you read the normal distribution. So let me go back to the normal distribution and just give you a quick recap. If you remember the normal distribution, this shaded area that you see here, right, in the graph on the top, that you will find inside the table. And if you wanted the corresponding z value on the axis, you just trace back. So say the area was 0.2054. If you want to know the corresponding z value, the axis, then you trace it back to 0.5, sorry, here's 0.5. That's how we find the z value. Everyone remember that? We given the area, and you can trace back the value on the z-axis like that. Oh, good. Okay. Okay. Now with the t distribution, it's the other way around. Okay. Your area is actually given on the top. Look at the graph, and if you're not sure, look at the okay. If you look at the graph, can you see in the top right, there's the shaded region, that's the area. And what it's telling you with the arrow pointing there, it's telling you that that shaded area is your alpha. So the area is alpha. And if you look at the first row, there's your alpha values. So you're only given 6 specific areas, 0.1, so 10%, 5%, 2.5, 1, etc. Okay, those are your different areas. So those are your different alphas. And if you wanted the value on the axis, then that is the value inside the table. And I'll show you how to determine which row you need to stop at. So for our case, if you look at our graph, right, what is our alpha? Remember, it's our level of significance. So what alpha are we looking for? We're looking for an alpha of 0.1. Anyone with me? Fantastic. So if we go back to our table, there's our alpha. Here, the first column, it's 0.1. But how do we know which row we need to stop at? And that's where your degrees of freedom comes in. And your degrees of freedom is nothing more than just your sample size minus 1. So in our case, your df, just some color here, your df, degrees of freedom, is simply just n minus 1. That's all it is. And our n is 18. So it's 18 minus 1, which is 17. That's what your df is. So now if you go to a table, where is your df of 17? It's here. So remember what we said? Our alpha is the first column, 0.1. There's your 17. And that's your value. Very good. Very good, everyone. Okay, so quick question, go back to the table. The t value is 1.33, but remember, this is the positive value, okay? This table only gives you the positive counterpart. So it's 1.33 on this side. Here it's 1.33. And remember what we said earlier? If we found this value, then all we have to do is just take the negative of it and place it as our left here. I'll remove this question mark now. And I'll write the negative value. So our critical value is negative 1.333. I don't need this anymore. I only used it to get the negative value. And so what we're saying is everything on the left of negative 1.33, we're going to reject H0. Anything on the right of it, we accept H0. Here we accept H0. And here, anything on the left of it, we reject H0. Does that make sense, everyone? Everyone with me? Let me know if there's anything unclear. This is your boundary. All good? Fantastic. All right. Right, fantastic. So that is your step 2 done. Okay, you found your rejection region, which is anything less than minus 1.333, you reject H0. Okay. Now let's move on to step 3. Calculate the statistic. And to calculate the statistic, you're going to use the simple formula in your formula sheet. Now I want you to pay very careful attention to this, right? I've seen students make this mistake. You've already established that you're using a t-distribution. You've done all the hard work. You've looked at the t-table, you've found df, etc. When you get your t statistic, make sure you use this formula. T, which is in your formula sheet, is t equals to x bar minus mu all over s over square root n. Make sure you use this formula because you're dealing with the t-distribution. Do not use the z formula. Okay, don't use this one. I'm writing it, but I'm just showing it to you. Do not write this instead because you'll get it marked wrong. Okay, don't use this formula because you're working with the t-distribution. So we're using this one, and all we need to do here is substitute the values. So remember, now we're on step 3. Forgot to mention that. All you need to do is substitute the values into this equation. Now we know our n is from the passage, it's 18. S is 788. And then you've got your X bar. That's the other one we need to find from the text. And if you read the text, it's telling you that, I'll underline it here. you had a sample of 18 supermarkets, so that's your sample size. And when you take the average of those 18 supermarkets, so the average of the sample, you get, oops, if you look at it, there's your average here. That's your X bar, 5275. So that's the average of the sample. Okay, so your X bar is 5275. 5275. So remember, I'll just quickly sketch it again. You had 18 supermarkets, right? And all the way to 18 of them. When you take these 18 and you take their sales and you average it, you get this here. That's what it's telling you. So that's the average of your sample of 18. So you have all the values to plug into this equation. For mu, for this mu here, you would substitute what you find in your H naught, which is this, 5,500. So maybe give that a shot with your calculator, plug all those values in, and tell me what values you get. And give everyone a time to calculate it. Hoping you got your calculators there, but if not, maybe I'll just get to it. Kai, I see you've got it already. So yeah, if you plug all those values in, you'll get a value of minus 1.21. Now look at where this minus 1.21 falls in your rejection or your acceptance region. Now tell me in the chat whether you're going to, based on what you get in step 3 and looking at what you have in step 2, are you going to accept H0 or reject H0? Very good. Everyone understands that? Anyone not clear on that, on how to interpret it? Just let me know if you're all good or happy to go back before. Because we're pretty much at the end of this. So yeah, I'm happy to just go back to step 2. All good? All right, thanks, Kai. Adrian, good. Kalisha, good. Fantastic. All right, so that minus 1.21 is actually greater than minus 1.33, so it's somewhere here. It doesn't have to be exact, but we know that we fall in the acceptance region. So step 4, all you need to do is, all you need to say is step 4. Okay, you can just say accept H0, right? And then step 5 is writing it in words. Now, this is why I wrote this little point here for H1. Now, based on what we found, right? If we were accepting H0, do we withdraw the product or not? Let's answer the business problem now, based on all this work. What's the consensus, everyone, in the chat? Withdraw the product or don't withdraw the product? Yes, very good. Very good. Because we are accepting this, we can rule out this. And that's how we're going to conclude. So I'll just clear the board here. And I'll write it in words. And remember, I told you before, always start off with your level of significance. Okay, that's very important. So we would say, based on a 10% level of significance, okay, we accept H0 and advise. You can write this how you want, but this is just my take on it. advised not to withdraw the product. And that's your step 5. Okay, so that's how you use statistics to answer business problems. All right, and hoping you see the value in hypothesis testing. That's it for Learning Unit 8. We're done with that. The next time I see you, we're going to start the last learning unit, which is the chi-square distribution. It's a bit different to this, but yeah, I will take you through it. But all good? Everyone understood the content in the session? Any questions? Nice, glad to hear it. All right, everyone, that's it from my side. But yeah, it didn't. But yeah, we'll chat soon. Enjoy the evening, everyone. Yeah, well, I didn't want to start the next learning it today, but we'll kick that up next week. Have a good evening. Cheers.